Just give me a second.
Sure, sure.
Give me 1 second. Give me 1 second. Sorry. That's
Okay.
okay.
Okay, can you hear me now?
Yeah, we can see your screen.
Yes, sorry. What were you?
Just,
Sorry, is there a lot of background noise? Sorry, I'm not in the best place right now.
no, a little bit, no worries.
Okay, sure. Then let me start.
Okay, sure.
So, okay, presentación de diapositivas. Okay, is anyone able to see my screen right now? Is it full screen?
Yes, it is. Yes.
Okay, cool. So, what I'm going to talk about, it's a paper related to how to reduce the cost energy on cloud for microservice. That is the main idea here: microservice, cloud, and energy optimization. So this paper propose a model called Allergy. Allergy, it's a combination of the words elastic and energy. And it's a model that allows you to reduce the amount of energy that you are using in cloud. What the paper is saying is that if you check the amount of energy that recent boot up machine is using against a machine with full charge, the one that just booted up is 70% is using the 70% energy against the full workload environment. So you only have a 30% difference. So having these idle instances is really expensive. You should I mean, it's this this paradigm that we also see with lambdas, right? For example, where you, whenever you need it, you create a new server where you can execute this code, and then you can, whenever it's not needed, the service will automatically disable that environment, so you can save on price. It's the general idea, just that here it is not handled by the cloud service provider itself. The user has a little bit more of well, not in this paper is proposed more to a different way to that the cloud server provider could do this resource allocation, right? So the main things here are, the goal is to reduce energy, because energy means cost. The second thing is we are going to use a predictive model. In this case, it's called ARAMA, Autoregressive Integrated Moving Average Model. In this case, what we are measuring is the CPU utilization. If your environment is idle, then you will have we want to check if it is idle or if it is in full charge, right? And the other thing here is that it is using a design pattern, which is a manager. We have a monitoring layer that is taking care of all this resource allocation, handling all these resources. So that is the main idea here. So the paper mentions a lot of different papers that are trying to do something similar to this. So the main differentiator of this is that it is using a mathematical model. There are some other approaches using machine learning, for example. It is focused in microservices because microservices allow us to fine-tune our systems. It is using an energy consumption treatment, and we want that the user has to do as less work as possible. For example, whenever you code elasticity, there are two ways to do it, right? It's with a proactive or a reactive approach. And all those stuff, it's based on, what is the name? It's based on thresholds, right? So we don't want the user to code those thresholds. In this case, the model is taking care of that. So the first thing is that we have an mathematical model that is used for prediction. It's a regression model that it's trying to guess what is going on the system, right? If we have a lot of customers or we don't have enough customers in the next hour, will that change? So based on that, it can take decisions. So this is a well, this is one of the things that it's important here. It is recollecting all this CPU usage, and based on that, taking decisions using this model. The second thing is it's focused on microservices, right? With cloud, there is well, it's not a new paradigm, but there is a best practice, which is you need to code everything as a microservices because it will allow you to scale in a better way, right? So the first thing is that because cloud it's oriented for you can have a lot of advantage of this. The developer needs to code everything as a microservice. That is one requirement to use this model. The second one is it will take all the decisions related to the energy consumption. Some other models try to optimize some other stuff, right? Probably the cost directly on the cloud provider, or it could be the CPU usage or some other stuff. This one is specific for energy. And as I said, minimal usage, the user should not interact here. In this case, what the model is doing is you have an upper threshold and a lower threshold, right? Well, actually, I will explain that later, but the main idea here is the system will handle this upper threshold, lower threshold, and based on that, it will decide when to allocate a new resource, when to terminate a resource, and to take decisions based on this, and it is transparent for the user. So how it works? The first thing is that we have several managers. We have one that is for the performance, and the other one is for energy, right? In the case of the energy, what it is doing, it's using bin packaging algorithm, which is called first fit decreasing algorithm, which means that if you have one, for example, in this server, you have the server that has highest CPU usage, and you have one that it's almost idle. So what it will do is evaluate every time the current status of the server, and based on that, it will say, okay, I can migrate this. In this case, our microservice I can move these microservices to server C and terminate the server A. If I do that, then I will, because this one is using 70% of the cost and it is idle, I can remove all that cost right away, and it will be better for my cost, right? Or final cost. So that is the main idea. You have idle services, and you will try to migrate them to a server where these services can fit. And you need to monitor in real time how they handle, so you can know if the task it's possible or not. Actually, if it is not possible, it won't try to migrate, because it's you shouldn't even spend time on that, because you know that it will fail. And in the second part, we have a performance manager. It is checking how many calls we are getting to these microservices, and based on that, if we know that we predict that we will have a peak in the usage of the application, then if we predict that and we assume that we need another system, it will create this new system, allocate the microservices, and handle all this stuff. And this is important because with the prediction, if you don't have a prediction, it could be possible that you allocate a service that you will not use, right? It's not really needed. So the prediction is really important. Now, okay. So this is like the high level diagram of the application of this model. And here we have LRG, which is the monitoring layer that I told you. It is taking care of these three things, which is the elasticity manager, which it is evaluating if we will have a higher workload or a lower one. So based on that, it can call an orchestrator and terminate or create a new resource. We have the energy manager that it's taking care of resource reallocation. And we have this metric collector. Each server has a tool that is reporting the amount of CPU that the system is using every 15 seconds. So based on that, it can build the prediction model. Additional to that, I mean, some important things that we might have here is we have an IP and a MAC address. I'm not sure if you are related with this term, but there is an option in some machines. Actually, it's very common right now that it's called wake on LAN. So you can wake up a machine that it's shut down using only the MAC address, right? Because at that moment, because it is down, it doesn't have an IP. You can request it to turn on using the MAC address. That is the reason why you need this information. The IP is to track all these servers, and the MAC address is to wake them up whenever it's needed. Because with the IP you can shut down, with the MAC you can start it up again. And you also provide an image repository, which mostly it's a Docker repository, Docker Hub, where the service, well, this model will grab the images so it can create new microservices. And well, you have 3 actors here, which is the cloud administrator, the developer, and the user, right? And you can see how everyone interacts with this. So, okay. How this project was validated. It provided, they tested it with 80 test cases from a sequential test case, which is once that the first task finishes, the second one will start, and some other related to parallel. They say that with these 80 test cases, they are covering all the real all the industry scenarios. So I mean, I'm not sure if that is really true, but that is the assumption that they are doing. And what they do is they test it in 4 different ways. An incremental way, which you assume that you are getting more users. A decreasing way, constant way, there is no movement, and a wave, which is like a sinusoidal test scenario where you are assuming that everything, your users are going up, and then they will decrease and come back. So they tested it with this way, and based on these values, in this all these tests, what they figured out is that there are some configurations that allow them to have good results. I mean, all these values are configurations that you provide to this prediction model. That, you know, in most of these prediction models, everything related to data analysis and well, all this big data stuff, you can fine tune your algorithm to have better results. So this is what they are doing. You have different options, and based on that, they get different results. What they say is that, for example, in this case, the 0 to 0, it's really good for incremental, decremental, and constant values, but the wave one, it's broken. It's not the best option. They allow you, they suggest some other values. So for example, this is like a more visual way to see it, right? The different, yeah. The blue one is the real one, and you can see how well the different prediction models are behaving here, right? I mean, it's not really linear. It is you will see like small squares here until it eventually more or less it will fit. So this is the thing. After doing all this research about this new model and how everything works, they have really good results in general. The main question that I have here is, I mean, testing it using a mathematical function. How is it really trustful? I mean, the results are really trustful because a prediction model, if you have a function, usually you will have the model will be able to fit, right? I mean, it's not, you don't have people working testing this. It's just a machine that is doing a function, and you have another machine that is guessing that behavior. So it's easier to test it, right? Because to have good results, because this prediction algorithm, it's trying to see these patterns, you know? So, I mean, this is like the general idea on what is going on, what the paper is talking about. So we have this this model that allows us to have an automatic scalable model that seems to be promising, but in real life, that is like the main question that I have, and I'm not sure if someone else took a look to the paper, but that is like the the doubt that is coming to me. But in general, that is the main idea here. I think that it was on a small paper. I'm just trying to summarize as better as possible. But yeah, I think that is everything from my side. Is there any question from anyone? Hello?
Nope. I think we should go to the questions that maybe could be more interesting. Well, the first question that I have is, well, since we have allergy right here, give me a second. For you, what is the main benefit that you see in allergy?
For me, it's the cost itself. For me, it was really interesting learn that an idle instance can be really expensive.
Mm-hmm.
So it's if you get out of all those idle instances, all the prices will be will go down. That is the main benefit for me.
Mm-hmm.
But I'm not my question. What I'm not sure is in real life how it will work, because for example, there is something that I missed. Sorry for that. Every time that you add a new resource,
mm-hmm.
it will recalculate the prediction algorithm, and it will take some time until it is ready again. So if you have a really high low of customers at some moment, of users at some moment, and the prediction model didn't really work, probably you will have a bottleneck.
Okay.
So yeah, that is my main concern here. Not sure if someone else has a different opinion than that would like to share.
I want to share my opinion, maybe because we have this issue that all systems sometimes are kind of on idle state. Since I work in cluster validation at Intel, so this can be implemented. Well, this implementation of LRG, I mean, it can be really helpful for the power consumption. That is an issue that we are having. I mean, this is in my experience, and I don't know if you have another opinion, another experience, maybe that someone wants to share.
So how are you managing it at the moment, Javier?
We're not managing. That's the problem. Basically, we try to run a bunch of workloads and try to don't get any system in idle state. That's why. But if we implemented, if we were able to implement LRG, it will be nice because we can save energy by this time, because I don't know, it's pretty hard to explain in terms of power consumption, but yeah, we don't implement this type of elasticity, but if we implement it, I know that we can save much energy as we can.
Mhm.
Okay, any other experience or something like that? If no, okay, let's move to the next question. So you said something about the first fit decreasing algorithm, but do you think this kind of algorithm can be optimal if we have, I don't know, 100 or 1,000 systems?
It might, but the amount of how to say it, this is an algorithm that it is assuming like the best what is the name of this kind of you pick first the best option, right? And always the first option might not be always be the best one. It's just a really quick algorithm, so you will have improvement, of course you will, because if you have 100 or 1,000 resources, you eventually will be able to kill 1 or 2 resources, right? But if it is the main, the better way to reduce energy usage, I'm not sure if it is the best algorithm. It is the cheapest one.
Okay.
I mean, I'm sure of that, but not sure if it is the best way to have a radical improvement. Not sure if someone else have other opinion on this.
Can you again explain a little bit this bin packing?
Yeah, so let's say that it sorts all the resources
Mhm.
based on CPU usage. So when you sort this, you will have 6, 5, 4. Actually, it is already numbered, right? Well, more or less. So you will place, let's assume that your bin is, I don't know, 10, right? You have a size of 10 units. So in the first one, you will place this one. In the second one, you will place a 5 and a 4, where probably you could fit without any issue a 5, a 2, and a 3. But that is the way that the algorithm works, right? And then you will place 5 and 4. Then you will move into 3, 3, 3. It will be allocated here. So it is just you order and you just pick, you place it in the bin in this case, and you keep placing until it is filled, until it is full, or you cannot place the next resource. So that is what this one is doing. Well, actually, Okay, it's possible that I missed something on the paper, because in this example, it's not happening that way, right? It is
Yeah,
picking up the biggest one and the lowest one. Yeah, probably I misunderstood something there. It says on the paper actually. Yeah. So the bin one is
Honestly, what I've learned here in mitigation is to give work to the other side.
or all my notes here. Well, bin.
Right there, Rodrigo.
Here.
Okay.
Okay.
I found it in Wikipedia. Yeah, it has like 3 steps or something like that. So it probably is easier if we see it there. There, in the order, the items. I was just following it.
Which one, in the 15?
Yeah. Yeah, filed the motion, but this is the motion that unfortunately lost due to failure to schedule an IBC.
Final motion, not fail. Fail on what?
Failure to schedule an IBC. No. This is, we found.
Okay, you
motions
can go
Yeah,
back.
I mean, let's not spend a lot of time of this, but
However,
It's basically disorder them, from largest to smallest, and then feed them as they come through.
we made it confirm and then we filed a motion. to
Okay,
confirm for your response,
so
right?
let me go to the next question. So imagine an hypothetical situation. You tomorrow go to the AWS and said, hey, AWS, you need to implement LRG in your cloud data center. What will be the maybe the main argument to try to convince them to use LRG?
However, we lost this motion due to.
well, in my opinion, it's exactly the same thing that we have been saying during all the presentation. It's the energy cost, right?
Mhm.
For AWS, the main priority is reduce costs, and what they really pay, it's the cost of the energy and the cost of the hardware, right?
Mhm.
And probably, I mean, the people that need to maintain those. So if you can reduce one of those really expensive stuff, it will be really attractive, right? Because actually we discussed that several weeks ago. The cloud sites, all these warehouses where these machines are there, they are really power hungry, right? So if you can reduce that, it's an advantage for the cloud service provider.
Okay. Well, in my opinion, yes, is more in matter of energy, because they said like 3 scenarios. The first one was with energy elasticity and using 2 initial physical machines. The second one was without elasticity using 2 physical machines, and the third one was the same, only using 3 physical machines. And if we have the table number 4, we can see that in terms of energy, between the workloads that this research paper applied, in the ascending, descending, and wave, we have a better energy, and even in wave, we have a better cost than in the other ones. So it can be useful maybe for cloud data centers in terms of energy, and maybe in complex workloads like the wave, it can be efficient in cost. Another thing is that they are using the Intel Xeon CPU before 2.10 gigahertz. This is almost a CPU from 8 cores, and it's a single socket platform. But what about if we transform in maybe a real situation, maybe a 2-socket system or a 4-socket system with a CPU of 100 or 200 cores, what will be maybe my question will be like this scenario that we have, it will be the same, or you think it can be? Do you see a trend more in the scenario that they are showing more than in the hardware? Because they say that that you can with LRG you can scale out and scale in. I mean, in terms of platforms and in terms of Docker containers, because they also mentioned in the last part of the paper about the Docker containers that are injected to this type of physical machines. But do you think the hardware can be a good I don't know, a good benefit if we increase the hardware capabilities on these research or in these scenarios?
What I'm thinking right now is based on this energy consumption, where you are just playing with the 70% to the 100, that 30%, you have more tolerance for idle instances in a bigger system, right? Because once that it is up, you can escalate with a lot of issues because you already have that 70%, right?
One big question that I have, and probably any of you know, is that what can waste more? I mean, what consumes more energy? A very big, powerful computer, or 2 small ones?
I don't know.
I mean, that's the big question, right?
Yes.
Because if we keep like tons of small computers, and then they don't really equate to a bigger one, then probably it's a good idea to have like tons of smaller ones, because in matter of energy consumption. But if it is better to have a bigger one because it has like less power consumption and we can get more microservices there, then the CPU would affect, right? It would really like make a difference. I mean, in terms of energy.
Yes.
But I can't tell for sure, to be honest.
But most likely,
Yeah.
the one that consumes, how do you say, the least is not proportional, right? I think that actually a bigger CPU consumes less energy than, for example, 2 small computers with the same capacity, and also you cannot perform exactly the same, right? Because there is always an overhead, right? Especially on components that you cannot escalate, and usually on the computer, the only thing that you want to scale, it's like the CPU and the memory, right? Not the other components that you need.
Yep.
And probably a bigger hard drive, it will not consume you more energy, most likely, than a smaller one, unless it's spin faster or it's solid state drive or something like that, right?
True. So I don't know, someone has another question about the topic?
Go ahead,
yeah.
Sal.
Yeah, I just have a little one. Do you know how long it will take to the user to see the benefits of implementing this technology? I mean, because if they try to implement this new approach to reduce energy, it will cost for the enterprise or for the business. So how long it will take to that the investment that they made to implement this will be returned with the savings, with the future savings? Do you have an estimate, or?
I think that it's subjective, right?
Okay.
Yeah, first of all, we need to check which is the cost of the additional resources, like all the monitor logic, storage, and that kind of stuff. But we never calculate the human hours, right? Which they are really expensive. So yeah, I cannot give you a real number right now. I can.
Yep, no worries. Thank you.
So the paper had a lot of results. I mean, why you decided to omit them, not to talk about them?
Which one, Madi?
I mean, the paper that you were showing now, they had so many more results, but you didn't talk about them. I mean, they weren't
Yeah.
important
No.
or
Well, yeah, I was not really on. It was a combination of at some point, I think that all the numbers can become really confusing. So, okay, yeah, but it can be really confusing. And I was not really able to order my head
Yeah.
to really explain those points, you know. I mean, what I noticed during the presentation is that all the architectural stuff was really well organized in my head, but once that we go into the results, I was not really sure how to share that, you know. Yeah, that was it's a personal problem more than yeah.
yeah, I get it. I get it. I don't know if there is any other question.
Only maybe I want to hear maybe your opinion, Maddie, because I'm really like worried about the way we are trying to handle. Well, only if you want. I mean, because we have this problem. I mean, in on the field on my current job, so it will be great to hear maybe opinions, not only for you. I mean, if someone has another opinion.
I don't think I can solve some problem that Intel as a company. You said you're working for Intel, right?
Yeah.
I mean, I am almost pretty sure I can solve a problem that is unsolved on Intel, you know, till day. I don't know if anyone else has a solution for a problem that exists currently in Intel at the moment. I mean, there might be some brilliant students here, but I personally, I don't have really. And a lot of these papers, I mean, how to say it? It's like I'm pretty sure like people like in Intel are aware of the latest developments. Okay, if you see there's like theories come in papers and when you see them, when you read them, when you see the result, they sound amazing. Everything sounds good, and you say, if this paper, for example, published 2-3 years ago, why we don't implement it really? Because it varies a lot actually what we see and read in papers with what you really touch and experiment in a real world scenario. So I'm not saying that the papers are worthless. Of course, that's not what I'm saying. But I mean, but when it comes to practice, it's totally different world. So if you see the problem exists, it means the solution is really hard. It's not like that easy. I mean, you may feel from one paper. So yeah, I mean, but if I mean, I'm pretty much sure they would grab it and they would apply it as soon as, I mean, even before even before we most probably we see it in papers.
Well, it seems like
In
Javier
certain
has
cases.
found out a subject for his thesis.
Mhm. Yeah,
Actually,
And a tutor, and a tutor. I think so.
Actually, my thesis project is about some another issue about Intel that we
yeah.
solved already. So there are a bunch of issues. If you want to come to Intel, you will have a nice thesis research. I'm sure.
Yeah. So if anyone looking for idea, you can go to Javier and help Intel. I mean, they're not
But
doing
well,
so fine.
I don't
recently.
think it's that easy because you can, if you don't work for Intel, I think they are not going to share the information with you or the data that is needed.
Yeah. So I was saying Intel has a library for thesis topics. So you mean open thesis topics or the thesis topic on Intel issues?
No. Well, sorry.
Yeah, I'm just saying that there are a lot of problems on Intel that could be solved. It's just a joking because there are a lot of problems that could be solved. So that's why
actually, these kind of problems are problems across the industry, on the semiconductor industry. Everyone that has interaction with hardware or even in the cloud will have. I mean, not only Intel, also AMD. So So yeah, there are a bunch of problems between hardware, software, and cloud.
I mean, totally off topic, but why is that an issue for Intel? I mean, we know Intel as a, I don't know, like, chip manufacturer. Why that's an issue in Intel?
It's not an issue. Basically, well, my research thesis is an implementation to solve kind of things that we are not checking in hardware validation. But
Okay.
I mean, in this type of paper in cluster, I mean, they don't care if they spend more money in energy because, well, I don't know how much energy they can save, but they don't actually care. They have the money to spend in this type of projects because if you sell the silicon, you will have better profit, and they don't even care about the energy that consumption that they are having. In terms of the thing is that it will be more interesting in the environmental way, more in the profit that they can have.
But what you're talking is not in the CPU level. It's in the basically fab level, right? Where they're producing.
Yep.
Mhm. Okay. Well, I mean,
So I think that Intel has NDAs with the Tech de Monterrey, so that shouldn't be a problem.
yeah. Or maybe that's a problem. I mean, we don't know.
So well,
For the
thank
comment, I mean, just it says here. Okay.
you. Interesting topics.
Yeah,
Well, thank you.
but no, thank you for presenting.
Thank you.
Yeah, thanks, Oscar, and thank you, Javier, for. And it's interesting. You touched actually. You were the one handling the discussion, and you have pretty good idea about the topic actually. So we can continue with the second one before break. So we have Christian Medina.
Yeah, sure. Okay, so it is visible, right?
Yes.
Okay, so the paper is a taste of scientific computing on the GPU accelerator edge device. And this here. Yeah, so a little bit of context. This paper came like 2 years ago, and it was approved by the Division of Computer Science Engineering University from South Korea. And it also has some help from or approval from Korea government. It is a short paper related to GPU edge devices and the start of art on this matter, all these subjects. So basically, it is about using GPU instead of the CPU for the edge, and how this can help in some of the most complicated tasks using the parallel computing instead of the serial task. So for example, with the new amount of growing number of mobile devices, which is that, as we have seen in this class, every day there are more devices connecting to the cloud and using more information, requesting more data from the servers. And not only the people, but also the devices keep using more and more memory, more resources. So it is a challenge how they move all these data from server to the device. And there are some challenges there, because at the moment there are some tests or benchmarks for CPU and for the deep neural networks, instead of using the GPU for some specific devices or task. So this paper talks about how this can be improved by using this kind of devices, specifically this one, which is a little one, similar to a Raspberry. They will be testing this against some other GPU hardware and see how it performs. So as we saw in the last Q&A, there are some questions about having one big computer versus smaller ones. So it's similar. So this one is called the Jetson Nano device, which is from NVIDIA. And during all the paper, there are some benchmarks. So let's see. It will evaluate these libraries from NVIDIA, which is this big GPU company using for video games, for rendering, and for moving a lot of data in parallel. Also has been used by other big companies such as Tesla, for example. So what it is said on the paper is that as we have more and more devices connecting to the cloud and requesting from servers, there is not really a benchmark study for these small devices compared with others. And the more similar one that the authors found was related to Intel using this specific processor architecture. And they are going to test and see how it performs. So this one is an example from Intel, just to compare. And the one that they will be using are some toolkit provided by NVIDIA for AI application. And we'll see how it performs with different environments and different tests. And it will be using this NVIDIA technology called CUDA for parallel computing. So basically trying to explore the benefits from using the GPU. So here are some very quick specifications for the devices that they will be using. And we have the Jetson Nano, which is the one that we just saw. The NVIDIA 28 Super, which is not like the newest one. It's like from 2 generations older from the newest one, but it's pretty decent right now still. So we have also the Tesla and some AMD desktop for the Ryzen 7, which has a different architecture from the other ones because it uses the GPU in a different way. So this is like the more technical specifications for that one. And this one is a processor that it can be found on laptops and desktop equipment. And one of the test evaluations, it will be a stochastic simulation application. So this is some combination of random clashes at a biochemical system, waiting for some functions to give a specific results. So it is just with the purpose to stress the machines and see how they behave against this kind of results. So there are some little explanation from this model and how it works on biochemical environments to explain like the mathematics behind it and why it causes so much stress for serial processors and how it can be handled by parallel computing. So in the paper, they also show some code about how this is performed and how they are inserting this into the devices. But as a small summary, it is like these 5 steps with the initialization, the calculation, waiting for the reaction time on the biological components, the system update and termination. All this just to evaluate the performance for this hardware. So if you can see more details in the paper, there are more specific line by line with the code that they're using to implement this on the device. So basically, they also mentioned that by using some of these methods, they were creating some stress on the components that, as we will see on the results, that was causing some major issues for this small device, for the Nano, and how it can impact when trying to handle a more complex scenarios. So this is basically how it works. It will be testing this task, which is the Jetson Nano, the desktop systems, and the server ones, trying to execute this parallel task and see how they perform by with the across the time, the temperature, and with the results returned to the user. So it's basically comparing a small device with bigger ones and more expensive ones. So they will be trying some small data and big data to try different scenarios and see how it keeps comparing and performing which small and across different sizes with these data. Another test, it will be with this message passing interface, which is also using the NVIDIA CUDA programming model. And is basically also similar with the JSON Nano iterations for how it behaves. So they will be providing all this information with different iterations. Yep. So here are some specific results for the metrics that they were calculating on these 4 devices and how it behaved. So as you can see, we have the mean, the standard deviation, and the different times they were testing this. So for example, in this one, it's easier to see the results. We have the graphic with the Nano, the Ryzen, the RTX NVIDIA, and the one from Tesla. And here we can see how it performs with across the execution time, and how the one that took more time it is Ryzen. And it says these results are kind of expected to see this linear in the graphics because on how this SSA simulation behave, independent from the devices. So pretty similar here. And also while testing the temperature changes, this behaves pretty similar, even we are comparing small devices with big ones. And every time they are increasing the size of the problem that the machine is trying to solve, as you can see on the problem size. So they also tested with some room temperature control, and they mentioned that even under those conditions, there were no big differences. So devices were performing pretty similar, no matter if you are controlling a very specific temperature or trying on natural environments. So then they moved to a different benchmark, which is the zero copy optimization. And they're trying to get advantage of the GPU devices. And here they were expecting to have good results, but the Jetson Nano architecture didn't support all the changes. So we'll see later on another slide how it caused some more problems by using this technique other than the previous one, where we saw that it was comparing like more similar to the big ones. So they talk about all these issues. They ran out of memory, and they will have some kernel issues where the hardware just stopped working and they were not able to track the results or measure any further result. This was because on the zero copy technique, they are trying a faster way to take the binary numbers from the hardware and moving to a different location, but skipping a few steps. So this this device wasn't able to perform that. And it looks like it is a architecture issue. So these are some of the other benchmarks that they tried, some of the common ones. Here are just the names for make it easier to read on the next slide. So as you can see, there are multiple ones, similar as when we are trying to buy a laptop or a desktop for personal use. We try to get like the best cost benefit. So if you have like some specific activities, like for home office or render application, or if you are trying to get the best for programming, and you try to get the specific benchmark that matter for you. So these are like some standards for parallel and for GPU. And here we can see the left one, and the most gray is the Jetson Nano. It didn't perform better than the others in none of the tests. And we can see in some of the graphics that there was this kernel issue where the process got killed before returning any result to measure. And in some of the cases, the Tesla one overperformed all the others. So in here, it would look like there is no way to compare all this hardware because of these results, especially because the ones that where the kernel got unable to keep processing the information. And here are some of the prices from same vendor, comparing the Tesla GPU versus this Jetson Nano. Even for the size, you can notice one is pretty small and the other has more muscle to move more bits. So all the challenge was to try to compare if it was worth it to use on all this edge computer. As you were saying, if we are having like multiple computers in one building, if it will have more benefits to have the big muscle and spend all this money, or having small computers handle this by maybe improving techniques, or if this one can handle better than using only CPU serial processing. So one of their conclusion was that the Nano wasn't able to handle all the stress from some of the experiments, and they suffer some head issue that make it impossible for them to keep working with the device and these specific scenarios. And they mentioned that for future work, they would like to use the N-body simulation and climate modeling to see how it performs and see if there are any other changes on the behavior, if they can achieve like better performance compared with these big devices. And also would like to try other smaller ones like the Jetson Javier and the Raspberry, which is currently on the 4th version. And while doing some research about this, I noticed this on the NVIDIA news page, which is a recent article for NVIDIA starting working with Microsoft to keep working on the cloud computer, which I found pretty interesting. So yeah, I like this paper because it's like testing these small computers for research and for university, and giving some metrics and benchmark to see if you as student or researcher can rely on small devices to test your scenarios and get an idea on how it will behave against some of the most expensive ones that has the market to offer. So yeah, that's it.
Okay, thank you, Christian. I think Saul is going to handle the discussion. But first, we
yeah.
can go with the question, if anyone has any question before Saul start. Go ahead, Saul.
Yeah, okay. So we have seen in the presentation that the authors directed an experiment using an edge device on scientific computing area. So I think it's a little unfair to compare a big processor or a big GPU with a small device or an edge device. But do you think that this type of experiments really helps to the industry to create better products? Or do you think that these kind of experiments are a misuse of these edge devices? Because at the end, we can see the comparison between prices and computing processing. And it's like David versus Goliath, right? So do you think this is this helps to the industry, or this is just a misuse of the edge devices?
Yeah, I also thought about when I saw it about David and Goliath, but yeah, it is useful in the way that if you are trying to do a research based on any of the methods that they presented here, where it compare more similar than the other ones, it can save some budget, especially if you depend on university or government to pay for that. Maybe if you try to request one of these expensive devices, that can be a blocker for your research. But if you can come with the smaller one, maybe to do some test, from there, maybe you can be able to request or get more funds to keep the research.
Yeah, and I think that the paper at the end in the conclusions show that the Jetson Nano device is the best cost-effective device, because at its tiny size and its capabilities, it outperforms better than the other processors. So yeah, in its own scale, the Jetson Nano is I think it's a good solution for, yeah, if you have a reduced budget but you need to continue with your research, yeah, I think it can help.
Yeah, especially for make like real scenarios on GPU instead of rely on CPU tests that may be different from what you're looking on in your research.
Yeah,
It depends of the application, because for example, I was talking about in my presentations about mining and blockchain. The Jetson Nano simply can't perform or solve the complex algorithms, and for that is are used the RTX GPUs. So Jetson Nano could be short in capacity. So it really depends, because I think Jetson Nano could be useful for simple tasks, like
Yeah.
sensing something or something like that. But
Yeah.
for powerful, also the GPUs consumes a lot more energy, but it's like that.
Yeah. Also, if you don't want like an overkill for small task because of the heat or the energy required, yeah, if that's no problem, you can rely on the Jetson Nano.
You won't rent a bus if you need to move three people. So yeah, that's kind of similar
Yeah.
thinking.
Yeah. Okay. Here's another question. Following these kind of experiments and considering that the edge devices, or yeah, these edge devices are becoming powerful, do you think that putting efforts on create powerful devices in a small size and low cost, do you think that those efforts helps to improve the processing capacity of the traditional GPU or CPU devices? So do you think that making edge devices or small devices, powerful, will help that, yeah, traditional CPUs will become more powerful?
Yeah, I think, like, for example, it will depend from creativity and specific scenarios. Like, for example, when Toshiba created the 16 gigabytes storage, they thought that was like not worth it. But when they presented to Apple, they decided to use it for the iPhone, and it was perfect to store like thousands of songs. So yeah, I think it will depend on the test case, but also from the creativity from developers.
I had the opportunity to work with Jetson Nano in my days in manufacturing, and they are very useful for kind of application in manufacturing floor, because you have a limited space and budget, and the space constraints allow you to use only a small hardware like this. And if there is, if they are powerful, they are more useful. For example, for monitoring, for vision systems, because it has a GPU strong enough to handle a large amount of vision algorithms. So it's very useful for that kind of applications like manufacturing and smart cities or something like that, because it's the space constraints is it's very important for example for smart cities, for example like traffic or system for monitoring velocity in the cars. I don't know, it's more easy to have a powerful hardware that is very little in space. So I think it's very useful for that kind of applications.
Yeah, I think David already answered my next question, but yeah, Javier, do you want to say something?
Nope. Only maybe I can share of the last question that you said that I think the comparison between the devices on GPU and CPU can be beneficial for all the semiconductor industry in general, because there are more and more even CPU desktop I mean hardware that is having different type of features, not only in cores or threads. I mean, they are increasing in either the accelerators or something like that. And even in the comparison, you can see that that in the Tesla B100, they have the HBM architecture on memory. That is the high bandwidth. Sorry, the high bandwidth. I don't remember. Well, this is the new type of like architecture. Yeah, high bandwidth memory. That's HBM.
HBM.
So this type of new technology. That's why maybe Tesla B100 is like better in terms of performance. But I think, in my personal opinion, Jetson Nano is really nice to do this type of workloads, as David mentioned, as artificial intelligence or something like that.
Yeah, I think Jetson Nano is it's a good option. So yeah, I think my next question was already answered, because these experiments or these kind of experiments were where they are trying to push a lot of stress on small devices. It is unfair, but it helps to the state of the art. So do you think that their benefits, we will see those benefits in the near or medium future, or the real benefits or useful benefits will be seen in a long term.
Yeah, maybe with more versions coming from Jetson Nano, we can see how they're growing against these big devices, if they're doing it in small steps, or if there are some specific tasks where they are getting closer to them. So maybe with considering the budget and the energy consumed, you can see that you can keep using them on your project and rely on them for that specific method or task that you are trying to complete or test.
Yep, that's awesome. I think I have no more questions.
Okay, thank you, Christian, for presentation, Saul, for handling the discussion. About the last point, the last thing that you said when you were doing research, you found Microsoft is collaborating with NVIDIA. I mean, anyway, NVIDIA is, I'm pretty sure you know, NVIDIA is, when it comes to server computing, NVIDIA is the best in the market, has the biggest market share comparing to Intel and AMD. AMD is recently getting more markets, basically, from NVIDIA, but NVIDIA is the one. So, I mean, there is no surprise seeing collaboration between NVIDIA, Microsoft, Amazon, because NVIDIA is ruling, basically, that space. So let's have a 10 minutes, like 9 minutes break, so we can come back by 8 p.m. and then we continue with the last presentation. Okay.
Thanks.
8. This talk is with a great topic, actually. Get your head out of clouds. I mean, after so
Yeah.
to the cloud. So you want to get our head out of the clouds. So yeah, it's a great title to wrap up the semester, cloud computing. So let's hear your talk. Go ahead, Saul.
Yeah, thank you. Yeah, it's a great topic because all this semester was all about cloud computing and how we can introduce us to that world. But at the end, we need to step out, right? So yeah, and this is all because the security of those clouds. So yeah, as Maddie mentioned, in this course, we have seen a lot of the cloud topics. What is cloud, benefits, concerns, the different models and the different architectures for clouds. But I think two of the most topics we saw in this semester was energy consumptions and the privacy. And yeah, I'm going to talk about those privacy and security about the cloud because yeah, I think we know that some aspects, since a third party are managed our resources, we can't trust on those resources or on those managements. So the main question here is that if we are sure that the clouds are secure, so it is not that they are not being hacked, but it also that our information. So the National Institute of Standards and Technology defines some concepts or some keys concepts for what is security, and they say that the data must be secure while it is in transit, when it is in rest, or it is in use. The data should be or must be controlled. That means only the authorized parties should access the specific data, and the data should be encrypted. So with this three types of consents. How secure is the cloud? So how the users can know that their data is safe. I mean, we know, and we have a lot of news that a lot of social yeah, that Facebook, that TikTok, and a lot of these kind of social networks leaked information, and they are also collecting all kind of information from our devices, from computing, from mobiles. So how can a user be confident that their communication only reach the intended recipients? So the answer is that no, that users can make sure that their data is safe or it is private. So for example, we know that WhatsApp or a lot of messaging apps knows the encryption mode in order to make sure that the information is being transmitted encrypted and only the recipients can see the information. But at the end, we are not sure that that kind of things is happening. So in this question or in this matter, the question is why? Because the author states that it is possible to access user information in real time without the knowledge of the cloud user or even the cloud service provider using a monitoring tool called virtual machine introspection or VMI. So using this kind of tools, it is possible to take information from any cloud. So the authors makes an experiment using the infrastructure as a service, because this kind of cloud model has the combination in terms of configuration, because some part is in charge from the cloud service provider and another part is in charge from the users. So, and also the IIS provides, it is the model that provides more control over the configuration of the hardware, because you are basically taking bare metal from the cloud provider, and you can install whatever you want over that bare metal. And also the authors use this approach called virtual machine introspections to monitor this IIS infrastructure. So, but what exactly is the virtual machine introspections? So it is an approach for inspect a virtual machine from the host machine to analyze what is happening inside that virtual machine. So let's remind some concepts. We know that a virtual machine is a software that uses virtual resources to act like a new computer. And the main part of the virtual machine is the hypervisor. So the hypervisor is the platform where that virtual machine runs. Let's say, I don't want to use this term, but in order to understand this, the hypervisor is like the compiler, or is the layer between the physical hardware and the virtual machines. So there are two kinds of virtual machines. The first one is bare metal, which is at the left. So the hypervisor runs over the hardware, directly over the hardware. And some examples is Microsoft Hyper-V or Oracle VM Server. And the second type of hypervisor or virtual machines is the hosted hypervisor, which runs on the operating systems. And a good example is Oracle VirtualBox and VMware Workstation. And this is a kind of obvious because we need to install VirtualBox on the operating system that we want to run our virtual machines. So if we take again the definitions, the VMI is try to inspect what's happening on the virtual machines, but mainly inspect the hypervisor, because the hypervisor is the one that it is in charge to allocate resources and to communicate the virtual machine with the host. So with all this terminology, what we can do with a virtual machine introspection, what we can do with the hypervisor, because at the end, the virtual machine introspection, what it does is to manipulate the hypervisor. And at this point, I would like to share with you some examples that I saw on internet that I think this is more visual for us to understand, because the examples that the paper shows are a little confusing, and it seems like it is like a forensic class. So I'm going to show with you this share sounds, and okay. Oops. I think okay, let's see. Okay, I'm going to share this first one. Please let me know if you can listen the audio. So, okay.
Yeah, we can hear it, but
it's too low.
Okay,
yeah.
let me try to.
The execution of Windows using the debug.
Yeah, can you hear it well
A
now?
little bit better, but it's still low.
It's still low, yeah.
Okay, I don't know what I can do. It's
I can hear you well.
yeah, okay.
Probably he can send the link and give like 3 minutes to watch that part. I don't know, but from the part where he starts, right? Because he's not starting from the beginning.
Yeah. You can do that, yeah.
Okay, I'm going to share this link on the chat. And I want to listen the first or the next 3 minutes. Just this part ends when when the console when the presenter changed the presentation. So the console gone.
So you can play it right now with us, so we'll come back to your talk.
So what you see there on the left is actually all of the system calls that are happening while.
But mute it so we don't hear it.
Sorry.
See, I can move the mouse around through VNC. And it is quite responsive, but as I move the mouse around, there's a lot more events spinning by, and it's totally impossible to see what's happening there even.
No, don't. You can.
Let's try to talk through that noise. I will show you a couple of things that are happening. So right now I'm grabbing for instruction pointer that tells me what functions are actually called within the Windows kernel. Here I'm not actually trapping the system calls, I'm trapping the internal kernel functions that result from the system. Another thing.
I can't hear anything right now because you silent the video. Yeah, it is mute.
Okay.
I think I'm going to wait 1 more minutes.
Okay, so everyone finished watching the first part? So let me share my screen so I can share it with the voice. Take the second video that he's thinking we need to watch it. It's minutes. So can you see the video?
Yep.
Yes.
Okay. Yes. So let's watch it.
And what I'm going to do here is actually hijack the execution of a process within that domain. So I have Task Manager running there, and I just printed out the list of what's happening there. And I'm gonna trap when Task Manager returned from kernel mode into user mode to execute calculator. And this has all happened from DOM0 without having any internal guest agent within the machine that you're monitoring. So what that means is that you don't even need to install anything within the system that adds to the attack base, right? You can use anything that's within the system already to do whatever you need to do with that system. So for example, if you need to execute a command, you can just commandeer any executing process within the machine and start up whatever command you need with the knowledge that it can't be hijacked because you control it from the hypervisor. So right now, I am going to inject a call to open Internet Explorer with some website of my choice. And it happens almost immediately. So this is a very handy feature if you're a sysadmin, right? You don't have to install anything within your system, and you can control it from the outside perspective. So when Amazon tells you that you are safe because they don't have the user credentials to your virtual machines, well, yes, that's true, but well, that's not gonna really get you much, because this is what you can really do with the hypervisor. So all of these tools that you have seen are actually part of a dynamic malware analysis system that will be published later this year at the ACSec conference. I'm actually releasing the tools here
you can share.
So I have a question. So, can you hear me?
Yeah.
Yep.
Okay. So the video is from 2014, right?
Yep.
So how many of those concerns have changed and things like that? Because from 2014 to 22, it's like 8 years. And
Yeah.
many things change probably, right? And also, especially on the operating systems and things like that, especially on Windows, I think, because they changed especially a lot of things to cloud-based, and also the kernel changed to Unix, right? And before they were using a different kernel. I don't remember when it was like that change, but a lot of things changed, right?
Yeah. Well.
But I think
Yep,
it's
go
more
ahead.
on the hypervisor, right? More than the system.
Well, yeah, right now, but either way, they were. That's because there is like another process recording all those processes, right? And then you can see exactly what commands you are executing. And my understanding is that if you know where those commands are allocated or where it's that's being logged, and then you can access a lot of information, right? And that you're not breaking like any system, because the operating system is recording all those things by default, right? So I don't know if they have looked for workarounds about these things. I don't know. And also, like, for example, I don't remember that version of Windows. I don't know which one it is, if it's, but also they are changing, well, the way they are changing it, right? So I don't know actually how much it has changed, but for sure, I'm sure that also you can access a lot of PII information, private information, let's say, protected information. And because I remember that also in the, how do you say, in the class for, what's the name of the class? The one that, where we were trying like to audit, like recover information from hard drive disk and things like that. We can see a lot of private information, right, from there, because that's on the registries.
Yeah, Forensica Digital.
In which one? Forensica Digital. Yes,
yeah.
on that one. But either way, I'm curious, like how this, if they are aware of all this, if they have changed something from that date to right now, right? Either way, I think that all our information is not like protected completely. Like nobody's safe in the world, right? Unless you don't exist. But
Okay. I think I'm going to address that question. Yeah, actually, one of the main concerns that the paper talks is that, yeah, what you said that I think 1 year ago in our forensic class, we know that we can see encrypted information. We can find deleted items or files. We can see the registers of the browsers, of the machine, of the RAM. We've seen a lot of things what we can do with the machines, but we need to consider that in order to do that, we need to have the in this case the file or the ISO, the ISO, the image of the operating systems, but that works in the traditional computers. But how you can make forensic on a cloud instance? Are you going to, for example, if you are using a SaaS environment, how are you going to ask to your vendor, hey, could you provide me your operating systems? You cannot do that. So that's why the authors mentioned this virtual machine introspection, which is a mechanism to try to address these kind of issues, especially in the forensic area. But this VMI, this virtual machine introspections, works on the host machine, it does not work directly on the virtual machines, because it is supposed that we cannot access to those virtual machines because you are in the cloud and because you are in a secure environment. So this VMI approach what it does is to manage the hypervisor, which is the layer between the host machine and the virtual machines. So, for example, in the videos, we saw that from the host machine, you are able to monitoring the process that you are running in your virtual machines. So you as the vendor, for example, Amazon, could install this virtual machine introspection and can start to inspect whatever is happening in your virtual machine without your knowledge. So you are not aware that something is happening in your virtual machines. So also in the video, we saw that we can monitor files or directories. And in the second video, we saw that that the presenter were able to inject execution of some processes. In this, for instance, he injects the calculator and he opens an Internet Explorer. But this was made directly from the host. It's in no scenario he access to the virtual machines. He access from the host, he access to the hypervisor. And manipulating the hypervisor, you can send information to your virtual machines. So as he said, if you think that for not know the keys or the access for the virtual machine, you are safe, that's a lie. So the authors, so we saw what the presenter can do with the virtual machine introspections, but the experiment that the authors directed was to extract TLC sessions from a browser, specifically from a Firefox browser. So through the hypervisor, they were able to take TLC sessions from the virtual machine, from the Firefox browsers. They also were able to extract keys or session logins from the LSAS and use those keys to inspect the network traffic that the virtual machine was making. And also they were able to decrypt file systems transparently. That means some files that were encrypted in the virtual machines, they were able to look at those files even being encrypted. And all of this was made through the hypervisor. So as I mentioned, can a cloud user detect if the VMI is being used, or even the cloud service provider can notice that a VMI is being running? And the answer is no, because as we saw in the video, when I don't know, is Thomas? Okay, it's Thomas, the name of the presenter. So we can see in the picture that he has or he opens the task manager, and the console is his host console. So whatever is happening in the host console, it is not reflected in the task manager. So you as user, we are not noticed that something is happening in your virtual machine, because the hypervisor runs below your virtual machines. So since it is running directly on the hardware, on the operating systems, your virtual machine never detects that something weird is happening in your machines. So yeah, as I said, there are no difference between performing operations with and without the VMI running, because it's almost unnoticeable. The authors directed an experiment trying to read a file from two kind of files, 10 megas and 100 megas files, with and without the VMI, and there are no noticeable results about this. So with all of this breach of security, what a user can do with these concerns? So are we still confident on the cloud security? So what the user can do is just try to trust in whatever the cloud service provider is doing. It's yeah, in the same way that that the CS that the cloud service provider may eavesdropping on the virtual machine to start information, as we saw on the experiment or in this paper. They can also use that BMI mechanism to try to monitor the behavior of the virtual machines. So, for example, in the same way that you are able to decrypt or to read information that it is encrypted, you can use those abilities to monitor that file in order to verify who is accessing to that information. So, for example, if you have, if your company has some files with business reports or some sensitive data, you can use this mechanism to monitor these special files. So if someone tries to access these files, you can verify who is accessing those files, if they are authorized to visualize that information. So in the same way that you can, if it's dropping the information, you can protect the information. So continue to answering the Paul's questions. The authors suggest two technologies to mitigate the problem, because we are not sure if we can put a solution for these kind of problems. And the first one is secure encrypted virtualizations, which is a technology created by AMD. And what it does is try to isolate the virtual machines from the hypervisor. So as we saw in the experiments, if we have these two parts in different, let's say, environments, we are unable to manipulate the hypervisor and send information to the virtual machines because they are isolated. So Intel has its own solution, which is software extensions, and it is a little bit different because the Intel solution is a hardware-based memory encryptions, and where the application code is isolated from the data in memory. So let's say that you are able to access the information of one application, you will be unable to transfer that application or to use that information in other application. So some conclusions about this paper is that the user must trust on the CSP providers to protect their data, because despite the cloud service providers provide some privacy control and security agreements, we are still not sure that they can that they are able to see our informations. And another key concept is that if we think that using AIS to have more control over the infrastructure and over the security, I think we're wrong. And we have seen that manipulating the hypervisor through BMI approach provides the ability to change the state and execution of the guest virtual machines. And yeah, it is possible to extract our information from the virtual machines without our knowledge or without the knowledge of our CSP. At the end of the presentation, I have some links for some resources. And yeah, I think that's it.
I just have one question.
Yep.
You say at the almost at the end of the presentation that the only thing that the user can do is trust.
Yep.
But we already saw one trust presentation. And my question is, which mechanism of the trust presentation should be used for trusting into security?
Mechanism, you are referring to the two last solutions, the AMD and the Intel, or?
No, there is always well, trust is a big concept, right?
Yeah, it's an abstract concept.
Yeah, and there are a lot of mechanisms for trusting someone. For example, when you are like with another person, you know something, you can trust in the person by experience, or you can trust in the person because someone else is telling you that you need to trust in the person, right? It's the
Yep.
same with cloud providers. There are different mechanisms for trusting into that into a provider or a service. So my question is like, which do you think is that trust mechanism that we need to use for trusting in a provider about security?
I think trust is one of the less things that the companies worry when try to hire or to use the services of a provider. And I mean the less, because companies when looking for a solution, they looking for price, they looking for benefits, they look for flexibility, they look for scalability. And yeah, the cloud service providers at the end gives you some agreements or some contracts where they tell you that your protection or your data will be protected, where your data will be managed with secure protocols, and they can tell you everything, and they can provide you with some evidence that they have good protocols for protect your data. But at the end, you are not sure what they are doing is what they are saying. I mean, the purpose of this paper was to demonstrate that using this approach, the cloud service provider could inspect your information and could steal your information. They can do it, but if they are doing that, you are not sure, and you can guarantee that they are doing or not doing that. So at the end, it's just trust in that simple way. I mean, you are trusting in what they are saying, you are trusting in what they are providing you, you are trusting in the documentation. If they have some certification on security, you are trusting on that. But at the end, you are not, you have no guarantee that they are not stealing your information.
Okay, thank you.
Okay, thank you, Saul. Presentation. If there is any other question before we start the discussion.
Okay, probably I can start with my questions here. So the first one that I have is, give me a second. Okay, so while I was doing my AWS certificates, I took one related to security, and one of the main keys here was we have trust. There are responsibilities from both sides, right? The cloud provider and the user. My question is, and we can see this kind of situations here, right? We are trusting the cloud provider, but probably the customer should take care of this issue by using an OS and hardware that allows you to use encryption and this kind of stuff. So the question that I have here is, do you think that all these responsibilities that are delegated to the user, is it because there is a technical limitation from the cloud provider, or if it is related more like a cost perspective, it requires more resources, development, research, or is it more like, for example, in the case that there is some issue from the cloud provider, they can clean their hands in a legal way, saying that you didn't do your part? So I'm not sure if someone has some opinion related on how we have this kind of responsibility delegation. Am I explaining myself?
Yeah. According to the authors, for these kind of problems, there are no solutions that it is in the user sides. At the end, it's the solution should be in the case of the AMD's technology and the Intel technology, those should be implemented by the cloud service provider, because you need to install these in your machines in the hypervisor which runs on the hardware. So according to the users, I mean according to the authors, the users doesn't have much responsibility on this, because at the end they are hiring the services of this cloud service provider. So what they can do is try to use from their side some security mechanisms, try to use good software. I mean, in the paper, the authors were able to read information from Firefox, for example. But what about other alternatives for software, for browsers? It is part of your responsibility to use good software, non-commercial software, or I mean traditional software. I think the user responsibility is try to use, let's say, strong software related with privacy concerns or privacy matters. But at the end, if you are using an IIS solution, you're with good knowledge about the software you're running, the vendors could stole your information.
Okay, but as you said, it's most of these cases are cloud provider responsibility, and they are not doing it. Do you know which could be the reason?
I don't know if they are doing it. I mean, at the end, and I think Pedro mentioned that there could be legal problems. But yeah, at the end, I don't know what kind of implementation the cloud service providers are doing on their infrastructure. In the author's approach, it's not guaranteed that the cloud service providers are doing these things. They are just showing that it is possible to do that things with manipulating the hypervisor and send information to the virtual machine. It is possible to do that, but they are not saying that the cloud service providers are hacking or stealing your information. So at the end, what the authors say is we need to trust, because we don't know what the providers are doing. We don't know if they are accomplish their requirements or security requirements. At the end, we don't know what they are doing.
Okay. The other question that I have, and it's related, it's a combination between who is validating what they are doing, what Pedro said, right? The trust meaning. One question that I had, and I'm not sure if someone is aware of that. Do anyone knows if there is some way, if there is some company that it's auditing, they do audits to these companies, so they can give you some certificate or an ISO or some, trust badge that we could use as a metric? Because I mean, we have talked about blind trust, but I'm not sure if in real life, I mean, usually someone makes money with that kind of stuff, right? So, well, that is my question. If there is a good way to audit this,
I think that is the mechanism that should be used for the companies when they need to trust in a provider, in a service provider or in a cloud provider, because that is the only way that we have there is someone else, a third party, that is like putting under the line their reputation. So yeah, I think that's the best trust mechanism for doing that.
Yeah, I mean, Fernanda put a comment that She doesn't remember, but they exist. I
Yeah.
mean, I knew one. I just Googled it. It's Electronic Frontier Foundation. They do more. I mean, I know them for their basically study on the different companies for privacy issues, mainly not for security issues, for privacy issues, and they usually go through terms and conditions of different companies because no one's going to read them. So they go through and they simplify it in a chart with some text, so you see just a chart that how they're dealing with your data. I think there should be certain organizations, certain foundation that they provide or they simplify or they give badge or they rank different companies. Yeah, there you go, Cloud Security Alliance.
Okay. Well, give me a second. I'm also the one that takes notes for this one, and I'm adding the comments here.
So yeah, there should be certain organization that they do that.
Probably also a magazine, IT magazine or something like that, right? That they do articles related to these topics. Okay. The other question that I have is, okay, let's say that what you are discussing here, it's cloud or not cloud, or if we want to have virtualization or bare metal. Do you think that moving into bare metal is fixing this issue, or just moving the place where you are having your attack surface? For example, I was thinking this one is different, right? Because the system is running, but with Kali Linux, you could be able to hack a Windows system, an ISO, and access everything that you want to. So of course, there are other ways to hack a bare metal environment. So do you think that, I mean, comparing the issues that you will have with one or the other one, is it worth it, the additional problems? Or, I mean, trust is the only option that we have for this kind of flexibility and time saving, cost saving, and everything that cloud is giving to us?
Yeah, according to the paper and the virtual machines architecture, there are two kind of virtual machines. The one which runs directly on the bare metal, and the second which runs on the operating systems. So I think wherever you are using an IIS infrastructure, you cannot make sure that using bare metal or the operating systems hypervisor, you can guarantee that you have the control. So since you're using a cloud provider, you have no guarantee that that one hypervisor is better than another. So in case you need to, or you want to have control, I think you need to run your own bare metal, because you have control on the main bridge issue, which is the hypervisor, because all this paper is about that, manipulate the hypervisor. So the only place where you can control the hypervisor is in your own bare metal.
Just one question here. It's an additional one that just came up to me.
Yep.
So that means that using a cloud provider always means that we will have an hypervisor. I'm not sure if there is some additional option in some cloud catalog for this kind of situations, because some customers, they like those casos de nicho. I mean, those corner cases that provide some. They have the will to pay additional for that kind of stuff. So I'm not sure if cloud always means virtualization. I mean, I don't know if they have some additional offering that could fix that. Not sure if someone is aware of that.
I think one of the definition of cloud is to use resources, computational resources on demand. So I think that, yeah, that's why I think that using cloud, you are basically talking about virtualization, because you need to run an operating system, you need to run some software on those bare metal. Either you need to storage or you need to run some process. At the end, using clouds, you need you are using computing resources from a third party, and you need to yeah, you need your virtual machine to run your business, because I don't think there exists another way to use cloud. Yeah, or maybe for if you, yeah, I think whatever you want to use cloud, where we are using one of the service model, infrastructure, platform, or software, but at the end you are using virtualization in different ways. So that's why the authors use this IIS model service, because this is the one where the user has more control over these resources. Yeah, the platform and the software as a service, you are just using what they are providing you. But yeah, I think talking about cloud, it's like talking about virtualization.
Okay, thank you, Saul. So that is everything that I have from my side. Not sure if someone have any additional question.
Any concern? The last concern of the semester.
I think when the authors are saying you need to trust, they don't mean you need to blindly trust. I think they mean use a service that you trust them. And they are not just, okay, you need to trust. I mean, okay, there are many service providers, so you need to trust them. But probably they mean trust. I mean, use the service providers that you trust the most, at least, right? Most probably, I mean, that's my understanding. Anyone has any other comments, questions?
I agree. If you are already on cloud, you accepted that at some level some time ago, right?
True. I mean, some people say that the privacy is a lost battle, so don't worry about it much. I mean, we already lost it, so. No question? Okay, so probably we're gonna. What was the title again? Get your head out of the cloud, right? So yeah, so let's do that. Let's wrap.
Yeah.
Thank you,
So
Saul.
yeah. Yeah, maybe this paper was a little dramatic, and yeah, I think make us think about the security concerns. But yeah, at the end, we need to be aware about the implication of use these cloud services. We can't just trust blindly on the services and trust that what they are saying is right. So, but yeah, we just need to be aware that our information is not secure on the cloud. So let's get your head out.
Yeah. I mean, the change comes with the awareness, right? I mean, the more aware people are, the more it becomes, the more concern, or more, how to say. I mean, when people are aware about something, there's more attention will be paid from every parties to that topic. So that side, yeah, we need to be aware about this topic for sure. Okay, so apparently that's it. We're done with the class. So before we finish, I want to to tell you that the ECHO is open, so you can go there, please fill it up. What else? Yeah, I mean, I wish we could handle the class a little bit better than this. I mean, I know we discussed a lot of topics, a lot of papers. I hope at least you learn a couple of things as I did during this course. I mean, the least thing is like getting used to reading papers. Okay, that's the least expectation, because I mean, if you learn how to get the knowledge from that, then you can get and learn anything that you wish for. So at least I hope you get that one. And apart from that, a couple of things here and there from cloud technologies. So there are few things that is still left. There are some assignment 3. The deadline is I don't know.
November 20.
Yeah, it's yeah, I can change the deadline. I didn't know, but when I set the deadline that the Monday is Wednesday. So I can move it more towards like 22, 23. So you can enjoy this this weekend, long weekend, if you have any plan, so you don't get busy with the assignments and submissions. So yeah, so let's say I'll set everything by 2023, next Wednesday 23. So you can have, if you come back, you can have 22 and 23, the whole things for the assignment, last things for assignment 3, and also the AWS course, if some people still haven't uploaded their certificate or the course that they did. What else? Yeah, please fill up the ECHO as well. And I don't know, anyone, any question, any comments?
I just want to review something with you after the class.
Sure.
Yeah, about the courses.
Okay. Any question?
Yeah, for the courses, I took one long enough.
Mhm.
It only it didn't send anything. Just a final screen that says thank you.
Okay.
That's I tried to capture the dashboard and that final path. Thank you. And is it enough to prove that it's done? Or
Yeah.
do you need? Okay.
I mean, as I said, there was, I don't remember who, but there was a question in the first class, like how you can prove that. It's like, I can't, right?
Yeah.
It's like the private information. Like, how can you make sure that they are not technically?
Yeah, it's the same. You have to trust. Like that's the keyword, right?
Okay.
So you have to trust. So yeah, I mean, yeah, sure. No. I mean, at the end, the idea is learning. So the whole thing, the whole assignment, write this, summarize that, read this paper, take note, prepare a question. It's all for forcing you, to read at least a couple of those papers, at least. Because to me, I honestly believe that that's the best thing you can learn. I mean, getting used to reading academic papers. Because that's the best source of information about anything you are looking for. So if you get that, it becomes a habit. Okay, you're seeing the paper, like 20-page paper, not freaking out that, oh, who's going to read this 20-page or 30 pages? Then that's a great achievement, actually. And the rest is, as Saul was saying, we have to trust, right? So yeah, that's it from my side. Please fill up the call again. I insist. And I don't know if there is no question, comments, we can finish. Hope to see you guys around Guadalajara or other part of Mexico, in campus maybe one day, hopefully. And yeah, take care, stay safe, and see you around, hopefully.
Thanks. Bye.
Yeah, like that one. Bye, Jose. Bye.
I just have one question.
Sure.
You already reviewed my assignment too? But
did.
I think the first one is not reviewed yet.
No, I
No.
check. I think that. Okay, I double check.
Yes.
I remember I did the second one that just 3 days ago. 2 days ago.
Yes,
But yeah.
but can you take
Yeah.
a look, please?
Yeah, sure. Brian, you need to check your assignment too.
Bad news.
I put the comments on your assignment too. I remember that. So if you see there is some assignment is not graded, please let me know. Or check the assignments, and maybe I put certain comments there, so you need to check.
Yeah, I uploaded the segment again. It was
Okay.
my mistake. Sorry.
No worries. Okay, sure. I'll double check.
Yeah.
Sure.
Sure. Thanks.
And yours, Alejandro, I remember. Yes, I remember.
Okay, thank you very much. Good
No,
night.
thank you. Bye. Take care. Bye. Bye, everyone.
Bye.
Ricardo,
Thank you.
Javier,
Have a good one.
Jerry,
Bye.
one question.
Sure.
The recordings of the last sessions are in the.
Oh no, I just right now actually I was I was checking that last one was 4 classes ago. I totally forgot to put the links for the apply. I will put all those sessions today.
Okay, thank you.
All the missing sessions link.
Yeah, okay, yeah, the last one is the session, the week 9, so.
Yeah, sure. Yeah, I will put everything. Yeah.
Yep, thank you.
Take
Bye.
care. Bye. Bye, Javier. Take care. Brian, Christian, Paul.
I have a quick question. But this is a part. It's because it's not about the class. It's about, are you giving another like distributed system class, or do you have others that you will give next semester? Or
Not sure, honestly. Is this yet? Not sure. I think distributed system course is gone, if I remember. So they are not offering it anymore. Because the whole degree is changed. I mean they are not calling it what you studied actually. So they're bringing AI stuff. Yeah, it's all about AI nowadays. I mean, everyone's talking about AI. But yeah, not sure. But no, I'm not sure really.
okay, yeah, it's because I was trying to find out exactly what I only need one more. How do you say subject, or how do you say class? Right? And I was like, which one should I decide? Like, because I don't know, or to suggest at least to Falcon, like from right now, because I know that there is like the winter season, and I will be like telling him like, put this one, put like. That's okay.
Falcon usually gives you a list of the course, so then based on the interest they will offer. If I'm not mistaken, that's how it works usually.
Yeah, but now I realize, yeah, I have to actually like start talking to a lot of people and start making the list. Like, all these people, we want this one, because I have spoken before, and he's like, no, nobody told me about this topic, and I was like, we're like 7 people that wanted that one, you know.
Yeah.
And
that's how I think you can convince Falcon to offer that.
yeah, that's why I will start pinging people.
Yeah, you need to make an army. Yeah.
Okay. Well, then see you later. Bye.
See you.
Bye.
Bye. Take care. Bye, Pedro.
Thank you, Amadi. Bye.
No, I have.
You are the one. Yeah, you're.
Yeah, I have something.
I'm not free to go yet to rest.
Yeah, let me share.
Bye, Rodrigo. We'll stay in touch. Okay, I'll get back to you.
Yeah, don't worry. I will wait.
Congratulations.
Thank you.
Bye.
No more chismecitos. Okay.
He's here. You can ask him later.
I will share my screen.
Sure. Fernanda, you.
Yeah. No, thank you, and thank you for the class, man.
No. Thank you guys for being patient with the papers.
Okay.
Take care. Have a good night.
Yeah.
Bye-bye.
Okay. I made these Oracle OCI courses. I made 2 of them. This is the first one. As you can see, there are like 26. In this case, I don't know why I cannot. Okay, in this case, you can see that it is 26 hours and
Mhm.
54 minutes. This is the screen there when I started the course. The course was on date is 25 October 25. This is one of them. The other one is this one.
Mhm.
I started this one. I forgot about the screenshot about this one. So this one is from 8 hours, just for 8 hours, September 30. But the
Yeah.
problem is that I finished the courses, but they are not 100% because for being 100%, I need to, you can see there are some skill checks here.
Yeah, yeah.
So they are tests. So I need to do the test for passing to the next, and then this will be 100%. But the problem is that if I do the test, it takes me like 3 times to do the course because I need to study. I need to, yeah, I really need to put a lot of attention on the course. So it's not like just watching the presentation, right? It's like watching, processing, and then answering a test. So for that reason, I have this one with that one, and this one with 95%.
Sure. Yeah, it's fine.
Okay, I'm going to upload those 4 images, so they are like the.
Yes, please. Yeah.
Yeah. Okay.
That should work.
Okay. So thank you,
So,
Maria.
was there any useful the courses?
Yeah, actually they are very useful because I need to do it. Well, it's not like I need to do it by force, but it's always a nice to have in the company having this one because at the end of the day, this is OCI and Oracle wants people to know OCI because if I am in Oracle, it's okay. I am using OCI, but if I go out of Oracle and I already know OCI, maybe I can recommend OCI for my next company or something like that.
Yeah, I get it.
Okay.
Good to know.
Thank you, Maddie.
Take care, Pedro. Hope to see you
too.
one day.
Bye.
Take care. Bye.
Yeah, bye.
Bye.